Here we're going to take a look at classification schemes for your data set. The data set we have to look at today is everybody's favorite topic of interest, COVID-19. This data set is from February 17th, 2021, and we're going to look at the recorded deaths per 100,000 for each county in the United States. The key here is to remember that how the data are presented may actually change the narrative of the story a little bit. In order to take a look at the different options for data classification, or as ArcGIS refers to it, symbology, is we right-click our data and we can zoom to symbology, and our symbology tab will pop up. They've done a bit of work on trying to explain what different classification schemes do, so they provided a bit more information within the updated platform ArcGIS Pro. So what we want to do is go ahead and take a look at primary symbology, where it says single symbol, and do a drop down tab. Alright, and there's a bunch of different options here. In this video, we're going to focus just on graduated colors. Alright, and we're going to go ahead and click that, and it'll take ArcGIS a second to load things. Alright, it has here defaulted to area land, as you can see. With the COVID data set as provided, we need to go ahead and fix that and say we want to pick, in this data set it's all data codes, but we will use org 1027.2. Sorry about that. This is the COVID deaths per 100,000 by county. So we can already begin to see a pattern here. All right, but the main point of the video here is to take a look at this methods. What methods do we want to use? All right, since this data set has already been normalized per 100,000, we don't need to use normalization. If we wanted to do this on the fly, we would actually have just raw COVID deaths, and we could divide it by population to get by population. Okay, this has already been set up for COVID death per 100,000. So methods. Jenks method is the default. If you do our drop-down tab, we have explanations here. Essentially speaking, the Jenks method is how the data itself break apart. And what we mean by that is we can take a look at how the data work themselves out and where the break values are based on this histogram. Alright, so we have high red cases down here, and most of our cases end up somewhere around this 32.19, somewhat 79.24. These are the presence, so there's more counties that stack up through here between 32.19 and 79.24. Somewhere over here. There's very few counties that are down in 273. So the presence of counties will begin to stack up again to build the histogram here. So we have Jenks method, and as explained here, numerical values of ranked data are examined to account for non-uniform distributions, giving an unequal class width with varying frequency of observation per class. Long story short is it's going to take a look at the data and try to find where there's actual natural breaks, okay, in the data set. It's what it defaults to. It's something to just be careful of. All right. We want to take another look at quantile. And with the quantile distribution, you will see the map itself change again. And what we're looking at here, because we have 5 classes, okay, we need to take a look at the histogram and see what it's breaking things down to essentially is. So this 9.03 would be our quote-unquote bottom 20% of values. And then all the way up here with 83.04, this would be our top 20%. Okay, and in between we have these values. So again, seeing how it affects our map, it's beginning to look very, very red down through the south and up in the Dakotas area, in Montana region. One other thing I wanted to say before we jump to the next method is with quantiles, I would recommend highly you stick with either 5 classes or 10. The reason being they're easier to understand because now we have top 10% and we have bottom 10% at 0 way down there, or a top 10% at 127 deaths per 100,000. So we go from quantile, we could jump to equal interval. These ones aren't, this one, equal interval, is not super useful. We could mess around with the ranges through here, reversing values, reverse symbol order, things along those lines. Shift these borders around. Where do we actually want the breaks? Okay, within equal interval, all right, it has already picked the intervals. If we go ahead and shift it, all right, it's jumping to manual, which is what we'll get to in a little bit. Manual is essentially you are shifting these to where you would like them to be. It doesn't actually matter where so much. I wouldn't necessarily recommend using, for the most part, either equal interval or manual interval or defined interval. These ones generally let the user, for the most part, define where the breaks in the data are. All right, again, we haven't changed any data sets here. We're just changing the presentation scheme. The main one that I think people get mostly hung up on is geometric interval. All right, let's read it real quick. Mathematically define class widths based on a geometric series, giving an approximately equal class width and consistency of frequency of observations per class. The main thing to pay attention to here is this consistent frequency of observations per class. And what exactly are we trying to say there? It's producing a result that arguably, I guess, is visually appealing and is data driven. Okay, but what the take-home message should be is geometric interval ensures that each class range has approximately the same number of values in each class. All right, and the change between those intervals that we see here, let me jump to it, are approximately consistent. With geometric interval, we have classes at 5, except for quantile. I would suggest for all the other ones, we would limit ourselves at an upper classification bin of 7. No matter how you slice geometric interval or Jenks method or etc., we do begin to see patterns developing down south, again up in the Dakotas, New Jersey, New York, Massachusetts, southern Texas, and things like that. Again, haven't changed any of the values, we're just changing the display. Finally, if we were to jump to standard deviation, for normally distributed data, class widths are defined by standard deviations. All right, this is involving more of a statistical background. All right, and interval size should be, we should definitely stick with keeping this one standard deviation as interval sizes. So if our data set is normally distributed, those that are 3 standard deviations away from our mean, all right, begin to show up highly in red. For the most part, 3 standard deviations, maybe 2 depending on the research question at hand, would be considered areas that we would want to focus attention on. All right, but for reference sake, all of these have their little selling points listed along with them. That generally is it for symbology. Again, we can move things around, changing upper values and scales and things along those lines. And histogram breaks can be shifted. All right, but it will jump this back to manual interval. The other caution is, like I said, this is already processed data by, I believe, the census or CDC or something along those lines. The computer will let us normalize it, even though it's already been normalized. So something to be careful of is, has the data already been processed? We do not want to touch this because it's already been processed for COVID death per 100,000. So let's just see. I would personally, if it were me, let's say I would pick quantile, and then let's say 10. All right, so we can see where the top 10% counties within the COVID death per 100,000 end up. Color schemes, we can switch these around a little bit down in here. I believe yellow to red is probably okay. Maybe we would go with blue through green. It's a little bit less smooth, but we begin to see that these purples are where we actually have serious issues. Okay. This probably wouldn't be publication quality. Generally, people like these flowing ones like this, for example, like we were just looking at, the flowing types of gradients and things like that. The thing to take home again is just be careful about which one we're picking and make sure that we're reading our documentation and giving this a moment's thought before we go ahead and choose our symbology. That's it for symbology and classification.